All right, we're going to talk about proportions. This was an example pulled straight out of our books describing the different ways you can set up a proportion. The scenario is we have a ratio of male to female doctors in the United States of 15 to 4, so 15 males to 4 females. And then they gave us the problem, well, if we had 450,000 males, how many females would we have? So we could write our proportion in 4 different ways. We could write our proportion, as you see in the top left here, 15 males to 4 females. So that's the ratio, 15 to 4. And that would be the same thing as 450,000 males to some amount of females. And we'll use our proportion to get there. Now, our proportion is 2 ratios that are equal. So we're going to use these 2 ratios. So we could have the ratio of 450,000 to X amount of females and say that's the same thing as 15 to 4. So we have the small ratio on the left, the large ratio on the right. If we go down below, you see that the small ratio is still on the left and the large ratio is on the right. That doesn't matter. We could have flipped it around. We could have put the large ratio on the left and the small on the right. That doesn't affect anything. But the only thing that's different now is instead of the guys being on top of the ratio statement, the girls are on top now. So we got the females on top. So we've got 4 to 15. Same information, same data. But if you notice on the other side of the equation sign over here, we've got to flip the males and females as well. So we have male over female, male over female, female over male, and female over male. There has to be that relationship there. So small ratio is one relationship, to large ratio that's another, or female on top, male on bottom. Okay, let's go over here to the right side. We have small amount of males to large amount of males to small amount of females, large amount of females. So again, we have male to male, female to male, or we notice the original ratio, that 15 to 4 and 450,000 to X. And then at the bottom here in the bottom right, we have large amount of male over small amount of male, large amount of female over small amount of female. Now, one thing I want to point out is that there is no relationship between the 450,000 males and the 4 females, or the 15 males and this large amount of females. There's no relationship there. So when we're going on the diagonal, we have no connection. So to set up the proportion, you have to set it up male to male equals female to female, or small male to large, small male to small female equals large male to small female, whatever. Okay? So let's look at some examples. Here we have a Ford F-150 has a 36-gallon tank. And that's true, I looked it up. If it gets 22 miles per gallon, how many miles can you get out of one tank? All right, so I see 3 pieces of information and 1 missing piece. My first 3 pieces that I see is I got 36 gallons, 22 miles, and then I know that 1 tank is, and this is miles per 1 gallon. So I want to know how many 1 tank gets me. Okay, so what can I do? Well, I know that 22 miles per gallon is 1 ratio, 22 to 1. So 22 miles per every 1 gallon. Okay, let me stop here real quick. First of all, please include these labels, because as you set up your other side of your proportion, you need to know that now I have miles on top of gallons. Miles on top of gallons. So, I need to have miles on top, gallons on the bottom. And this is, again, this is just one way of doing this. I could have had miles and miles and gallons to gallons, but I chose to do small amount of miles over small amount of gallons equals large amount of miles over large amount of gallons. Now, I don't know how many miles, because that's actually the question. How many miles? So there's my variable, x amount of miles. And then how many gallons do I have in one tank? I have 36, according to my information provided. So there's my ratio proportional statement. Now, I could solve this two different ways, scale factor or ratio. I'm thinking scale factor looks a lot easier. My scale factor from 1 to 36, I know that pretty quick. I'm multiplying by 36. So if I'm multiplying 36 that way, I must have to multiply by 36 this way in order for it to be an equal ratio. So what is 22 times 36? Well, we'll get out our calculator here. 22 and times button right there. 36 equals 792 miles. That's a lot. So x equals 792 miles. Again, label. Label, 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 so that you do not get confused. Now, I could have solved this going ratio. I'll do this in red. Red for ratio. What is 22 divided by 1? Well, that's 22. So that I know now x divided by something, or x divided by 36 has to equal 22. So I need a bigger number on top, so I must be multiplying 32 or 36 times 22. And that's another thing I want to point out, is as I look at my proportional statement, the number on top over here is larger than the number on the bottom. So that means over here, my number has to be larger in order to have that same relationship. Or I could look at this as my number over here on bottom is smaller than this number here. So my number over here must be bigger and this one be smaller. Okay, because I'm growing this way. Or you could say, hey, I'm growing up this way. It just depends on how you look at it. And how you look at it is completely up to you. It doesn't matter. It's entirely up to you. Whatever makes the most sense to you, you do it, and do it well.